In this session, we will learn how to name ionic compounds that have variable charge cations. In other words, those compounds in which the magnitude of the positive charge on the cation can be different. For example, copper can actually make two different ionic compounds with oxygen. One of them is copper CuO, the other is Cu2O. What is the difference between these two compounds? The difference between these two compounds is that the cation, the copper ion in both of them is different. The magnitude of the positive charge on each of those is different. And such cations are called variable charged cations. Now, which metals in the periodic table will make variable charge cations can easily be figured out if you remember which metals in the periodic table will make fixed charge cations. From a previous session, you might remember that alkali metals, alkaline earth metals, aluminum, gallium, zinc, cadmium, and silver are the only metals in the periodic table that make cations with a fixed magnitude of the positive charge. You need to know what those charges would be. But besides those, or metals except for the ones that will make such cations, are all the metals that will make variable charge cations. So if you look at the periodic table, silver is going to make fixed charge cation, but gold or iron or copper or cobalt, nickel, tungsten, rhenium, osmium, molybdenum, zirconium, platinum, all of these elements that are not included in the list of those metals that make fixed charge cations will make variable charge cations. Now, when you're dealing with ionic compounds that have fixed charge cations, such as, let's say, calcium chloride, it is very easy for you to write out the chemical formula because we know that calcium ion will have a charge of 2 plus because it is a fixed charge cation. It cannot have any other charge. And chloride is from chlorine, therefore the charge is -1. So if you put these two together, the chemical formula for calcium chloride is CaCl2. There is only one calcium chloride possible because, again, that the calcium ion can only have one magnitude of the positive charge. But when we talk about copper oxide, as you can see, there are two different copper oxides present. Both of these are copper oxide, but they are not the same compound. They're different. So the name of such compounds has to indicate or has to clarify that difference. In other words, the name of these compounds has to clarify the difference in the magnitude of the positive charge of the cation in each of these compounds. Now, before you actually name the compounds, therefore, you need to know what is the magnitude of the positive charge of these compounds. For example, you should be able to figure out what are the ions present in such compounds. So, here is an example of a compound. Gold, if you notice, is a metal that will make variable charge cations. So, our first job before we can even name such compounds is to figure out what is the cation, what is the magnitude on the cation, and what is the anion before you can name them. So let's do that. So the question is identify the ions in these compounds. It is not enough to say that that's the cation, It is not enough to say that this is the cation and this is the anion. Please don't do that. You have to specify the charge as well. So first thing we have to do is we have to work out the charge. The best way to figure out the charge on the cation is from the charge on the anion. In other words, when you see AuCl3, that says that one formula unit has one gold ion. We don't know the charge just yet, so I can't write it. And we have 3 chloride ions. What is the magnitude of the negative charge on each chloride ion? Exactly, it's -1 because chlorine is in group 7. So if that is the case, what is the total negative? 3 minus. Do you remember what is the total charge of the entire formula unit? Exactly, the entire charge, excuse me, the net charge of the entire formula unit has to be 0. If that is the case, then what must be the charge on the gold ion in order to give us a neutral formula unit? Exactly. In this case, there's only one gold, so that gold ion has to have a charge of 3 plus. In other words, the answer to this question would be the cation is gold 3 plus and the anion is chloride Cl minus. Of course, there are 3 chloride ions, excuse me. You can definitely write that, and if you wanted to write that, if you wanted to indicate that there are 3 chlorides, the 3 for that would have to go in the front of the symbol, such as that. You can definitely do that as well. Now let's answer the same question for PbO2. Once again, going through the same process, one formula unit of PbO2 has 1 lead ion and 2 oxide ions. Each oxide ion has a charge of 2 minus. And please remember, the entire formula unit should have a charge of 0, which means that the lead ion must have a charge of 4 plus. So cation in this case is Pb4 plus, and the anion in this case is oxide O2 minus, or you can say also that there are 2 O2 minuses because there are 2 of those. Okay, now I would ask for you to pause the recording for a couple of minutes while you answer the same question for this next compound. If you worked it all out correctly, remembering that the anions are sulfates, so in this case you have 2 titaniums in one formula unit and you have 3 sulfate ions in one formula unit. Each sulfate ion has a charge of 2 minus. How do you know this? You memorized this in the previous chapter, so you do need to remember that, which means that the total negative charge is 6 minus. And remember, the overall net charge of the formula unit has to be 0, which means that the total positive charge has to be 6 plus. But now that 6 plus is being shared by 2 titanium ions. So what should be the charge on each titanium ion? Exactly. Each titanium ion will have to be 3 plus. So the answer to this question will be that the cation is titanium 3 plus. Of course, there are 2 of those, and the anion in this case is sulfate, and there are 3 of those. Please remember, when you are giving the ion, no matter whether it's cation or anion, you must give the symbol, but you must also give the charge. Without either of them, the representation of the ion is incorrect. Okay, so the naming of compounds that have variable charge cations is very similar to that of naming of ionic compounds with fixed charge cations. First step is we name the cation using the name of the metal without any change. But as I said before, for when you're naming these compounds, you have to specify the magnitude of the charge on the cation. And that is the difference between the 2 categories of ionic compounds. In this case, after you name the metal, you must give the magnitude of the charge. Must give the magnitude of the charge on each cation as a Roman numeral in parentheses after the name of the metal. Together, when you do so, together, these 2 steps are naming the cation. So the name of the metal and the magnitude of the positive charge written as a Roman numeral in parentheses, that together is the name of the cation. Once you've named the cation, we name the anion exactly how we did before, using the stem of the non-metallic name and attaching the suffix "ide." If if the anion happens to be a polyatomic ion, then we do not change the name of the polyatomic ion at all. So let's try it out. Here is a compound. Is this ionic? Yes, it is ionic because it has copper in there, which would make a cation, so sulfur is therefore making an anion. Is it a fixed charge or a variable charge cation ionic compound? It is a variable charge cation because copper does not make fixed charge cations. Okay, so now we need to name those. Now please remember, you cannot figure out the charge on variables on such metals from the periodic table. You have to work it out from the anion. So here are the steps again. Since copper is a metal, it will make a cation. There is never an exception to that rule. Now, since sulfur is a non-metal in group 6A, it will make an anion, meaning it will have negative charge. But how many negative charges? Since sulfur atom has 6 valence electrons, it will accept 2 electrons in the valence shell to satisfy octet rule. Therefore, the charge on the sulfur ion, the charge on sulfide, is 2 minus. And if the charge on sulfide is 2 minus and overall the formula unit has to be 0, then the charge on the copper ion has to be 2 plus in this compound. In other words, when you're naming this compound, we give the name of the cation using the name of the metal and the magnitude of the charge on each cation as a Roman number. Now this step is extremely important when you're naming the such compounds. Without this, the name is incorrect. That is the name of the cation, and the anion, of course, in this case is sulfide from the name sulfur, and the compound therefore is called copper 2 sulfide. Okay, let's try out a few more of such compounds. Now once again, here we have another ionic compound in which the metal will make a variable charge cation. So work backwards, people. Since Ti3N means there are 3 Ti's and 1 N ion, what is the charge on the anion, the magnitude of the charge? Exactly, nitrogen is in group 5A, so the charge will be 3 minus. If that is 3 minus, what will be the charge on each titanium ion? Will have to be plus 1, because if each titanium ion is plus 1, then the overall charge of the formula unit becomes 0. So now we are ready to name this compound. In order to name this compound, we give the name of the metal, titanium, followed by, in parentheses, the magnitude of the charge on one cation. This total is the cation, and then the name of the anion comes from nitrogen and becomes nitride. Once again, I would like to point out to you that this is the name of the cation together with the Roman number, because that gives the magnitude of the charge on one cation, and this is therefore the name of the anion. Okay, go ahead, pause the recording and name the following compounds following these set of steps. As we name such compounds, it is important to not only go from the chemical formula to the name, but we should also be able to write a chemical formula from the name. For example, chromium 2 sulfite. As we said before, it is very important for you to remember that the name of the metal together with the number is the cation. And then this is the name of the anion. What you need to do is here first write the symbol of the cation. So what is the symbol for chromium? It's Cr. What's the charge on this cation? Please remember, this number does not give us how many chromium ions there are. This number instead gives us the magnitude of the positive charge on each chromium ion. In other words, the cation is 2 plus. The anion sulfite, since it's ending with an ite, you need to remember that this is a polyatomic anion which you had to memorize, and that is SO3 with a charge of 2 minus. When you put these two together, the the chemical formula of the ionic compound becomes CrSO3. Okay, go ahead and pause the recording for a few minutes while you go through the list of names and write the corresponding chemical formulas. Okay, let's check our answers. Make sure that you are following the steps and that your answers match mine. Once again, as a highlight, as to reiterate the important point here, I must say that the Roman number in parentheses after the metal name gives us the magnitude of the plus charge on, and this is important, each cation. So please highlight this statement because it is something that you have to remember. Excuse me, it doesn't give you the number of cations. Instead, it gives you the magnitude of the cation in each of the ion. Without giving that information, the name of such compounds is incomplete.